Hello students, in this video we are going to study how to calculate the equivalent masses of oxidants and reductants in the oxidation reaction. Okay, this can be calculated by taking the formula mass divided by N. N represents the number of electrons gained or lost by that oxidant or reductant. Okay, what is the stoichiometric? Actually, we need to take the formula mass according to the stoichiometric equation. You will understand this when we get into the examples. Let us see this example first. KMNO4, okay, potassium permanganate oxidizes the oxalic acid. Okay, you might have done this sort of experiments in your volumetric analysis. Actually, this is the estimation of oxalic acid by KMNO4. KMNO4 is the oxidant here, oxalic acid is the reductant here. Okay, now we are going to calculate the equivalent masses of this KMNO4 and oxalic acid. Let's come to the KMNO4. Okay, the equivalent mass is equal to formula mass divided by N. What is the formula mass? Okay, there are 2 KMNO4. So it should be taken as 2m by N. Okay, that is what I said, the formula mass according to the stoichiometric equation. Okay, according to a stoichiometric equation, there are 2 KMNO4. That is why 2 into molecular mass of KMNO4. 2 into m. M represents the molecular mass of KMNO4. Okay. Okay, what is N now? See the oxidation state of manganese. Here it is plus 7. Here it is plus 2. Okay. What is happening? 5 electrons are accepted. But there are 2 manganese. For 1 manganese 5 electron means 2 manganese 10 electron. So N is equal to 10. Okay. 2m by 10. Okay. Which is equal to m by 5. Okay. M by 5. Actually, the molecular mass of KMNO4 is 158. Okay, divide by 5, that is equal to 31.6. Okay, so the equivalent mass of KMNO4 is 31.6. Let's come to the oxalic acid. Formula mass. Look at the number of oxalic acid, that only one molecule. So m by n. What is n here? You see the number of the oxidation state of this carbon here, it is plus 3. Here oxidation state of carbon is plus 4. I hope you know how to calculate the oxidation number. In case if you have any problem, just write it on the comment box, then I will upload a separate video for that. At present, let me assume that the people know that and let me proceed. Okay, so here it is plus 3, here it is plus 4. So what is happening? 1 electron is lost. Okay, but actually there are 2 carbons. So into 2 is equal to 2. So N is equal to 2 here. So m by 2. It is almost 63. The equivalent mass of oxalic acid here is 63. And regarding this KMNO4, okay, we knew that it is 31.6. But remember, it is under acidic condition. You see, KMNO4 in the presence of sulfuric acid. Under acidic condition, the equivalent mass of KMNO4 is 31.6. But in basic condition, it is different. Okay, so in basic condition, Mn plus 7 to Mn plus 4 actually. In acidic condition, it is not like that. Plus 7 to plus 2. But in basic condition, plus 7 to plus 4. Okay, it is reduces from plus 7 to plus 4. So what is the difference here? Only 3 electrons. So N is equal to 3. So here m by 3. That means 158 by 3. That is equal to 52.7. The equivalent mass of KMNO4 under basic condition is 52.7. Under acidic condition is 31.6. The reason is the difference in M. In acidic condition, N is 10. In basic condition, N is 3. Okay, so it exhibits different equivalent masses under acidic and basic conditions. Okay, let's see this example. Potassium dichromate oxidizes ferrous sulfate. So estimation of ferrous sulfate by potassium dichromate. Okay. Let's calculate the equivalent mass of potassium dichromate. There is only one molecule, so equivalent mass is M by N. What is N here? What is N here? Here N, here plus 6, here chromium plus 3. So that means 3 electrons. But there are 2 chromiums on both the sides. So into 2 is equal to 6. N is equal to 6. So M by 6. So this is the equivalent mass of potassium dichromate. Come to ferrous sulfate. There are 2 molecules of ferrous sulfate. So 2M by N. What is N here? What is N here? Here plus 2. Here it is plus 3. The oxidation state of ferrous ion. Okay, ion is 2. Here plus 3. Okay, so that means 1 electron is lost. But there are 2 ion. So into 2 is equal to 2. So N is equal to 2. So 2M by 2 is equal to 2 cancel M. The oxidation state of ferrous sulfate is nothing but its own molecular mass. The equivalent mass of ferrous sulfate is its own molecular mass. Okay. Let's see the other example. Sodium thiosulfate reduces iodine into iodide. Okay, sodium thiosulfate is the reductant, iodine is the oxidant. Okay, so let's calculate the molecular equivalent masses. There are 2 sodium thiosulfate, so 2M by N. What is N here? What is N here? Look at the sulfur. Okay, here the oxidation state is plus 2. And here the oxidation state of sulfur is plus 2.5. So that means 0.5 electrons lost. But there are, look at 4 sulfur. Here also 4 sulfur. So into 4 is equal to 2. So N is equal to 2. 2M by 2, which is equal to M. So the equivalent mass of thiosulfate is its own molecular mass. Okay. Let's come to iodine. There is only one iodine. So M by N. Okay. What is N there? What is N here? Here N is here 0, here minus 1. That means 1 electron is gained. But there are 2 iodine. So into 2 is equal to 2. N is equal to 2. So M by 2. Okay. Equivalent mass of iodine is its molecular mass divided by 2. Okay. Let's see the other example. Okay. This one, potassium dichromate, we have already seen. M by 6. We have already seen it. Okay. Let's see iodine. Okay. Iodine. There are 6 molecules. So 6M by N. What is N? Here minus 1 and here 0. That means 1 electron is lost. But there are 6 iodine both the sides. So into 6 is equal to 6. 6N is equal to 6. So 6M by 6 is equal to M. Is equal to M. Okay. The equivalent mass of I minus. Here I minus means it is potassium iodide most probably. So the equivalent mass of I minus is nothing but its own molecular mass. Okay. Let's see this example. Yeah, this is very important. Disproportionation reaction. Look at this. The oxidation state of chlorine is 0 here. Here minus 1. Here plus 3. Okay. Chlorine reduces into chloride. and the same chlorine oxidizes into chloride ion. Okay, so oxidation and reduction both take place simultaneously. This sort of reactions are called disproportionation reaction. When a same species undergoes oxidation as well as reduction, then that reaction is called disproportionation reaction. Okay, right. So here in this case, the equivalent mass of the species that disproportionates cannot be found out as we have done in the previous cases. Here it has to be dealt in a different manner. Okay, actually we need to take up the two reactions. Let me take this reduction first. Cl2 gives Cl minus. This is reduction. Again, if I write the oxidation, Cl2 gives O2 minus. This is oxidation. So I have to calculate the equivalent mass of this oxidation and this reduction. Then I have to add both. Okay. So if I take the equivalent mass for this is reduction. Okay, let it be 2 chlorine, here 2 chlorine, here 2 chlorine, let it be balanced 2. Okay, right. So this is reduction, only one molecule of chlorine, so M by N. What is N here? Here 0, 2, minus 1. That means 1 electron gained, but there are 2 chlorine into 2. So N is equal to 2, M by 2. Okay, this is ER. And let's come to this one. E oxidation, okay, is equal to only 1 chlorine. So M by N. What is N here? 0, 2 plus 3. That means 3 electrons are lost. But there is 2 chlorine. So into 2. 3 into 2, 6. So N is equal to 6. So M by 6. Okay. So E net is equal to E reduction plus E oxidation. Equivalent mass. The total equivalent mass, net equivalent mass is equal to equivalent mass for reduction plus equivalent mass for oxidation. That means M by 2 plus M by 6 is equal to 2 by 3 M. Okay. This is the equivalent mass of chlorine. Okay. Because it undergoes disproportionation reaction. So when it undergoes disproportionation, it has to be calculated differently. First oxidation and reduction, then add both. Okay. And that is the net equivalent mass. And that is the equivalent mass of the species that disproportionates. Okay, 2 by 3 M is the equivalent mass of chlorine. Okay, let me give a homework. You can do it at home and write your answers in the comment box. MnO4 2 minus gives MnO2 plus MnO4 minus. Okay. Please calculate the equivalent mass of MnO4 2 minus as we have done in this case, the previous case. Okay, do it at home and write your answers in the comment box. Okay, let's go to another example. What is this reaction? Formaldehyde in the presence of base gives formate and methanol. What is this reaction? Cannizzaro reaction, yes. Why should we do, what is the need of that reaction here? It seems irrelevant to the context we are discussing here. This is an organic reaction, but we are discussing here redox reactions. Of course, it is relevant. See, formaldehyde and acid. What is the relation? If you oxidize aldehyde, you will get acid. Again, you compare aldehyde and alcohol. If you reduce the aldehyde, you will get alcohol. That means formaldehyde undergoes oxidation. That's why you get acid. Formaldehyde undergoes reduction. That's why you get alcohol. That means this is a disproportionation reaction. Okay, formaldehyde simultaneously undergoes oxidation and reduction. Okay, there were questions asked in the exams previous days, Among the following reaction, the one that undergoes disproportionation is option A, Cannizzaro, option B, aldol condensation, option D, Rosenmund, option D, some other naming reaction. Then you have to select Cannizzaro reaction, because Cannizzaro reaction is an example of disproportionation reaction. Okay. Now we are going to calculate the equivalent mass of formaldehyde here. Okay. As we have done in the previous case, write two reactions. Okay, let me write the oxidation first. 2HCHO gives HCOO minus. And if we write the reduction, 2HCHO gives CH3OH. Okay. Okay, let it be balanced. Here 2 carbons. Okay. Here also 2. Okay. So here E oxidation is equal to, there are 2 molecules, so 2m by n. What is n here? Here the oxidation number of carbon is 0. Here oxidation number of carbon is plus 2. Okay. And here oxidation number of 0 we know already calculated, and here carbon it is minus 2. Okay. So how much? 2 electrons lost. Since there are 2 carbon into 2 is equal to 4. Okay, n is equal to 4. So 2m by 4 is equal to m by 2. And let us come to this one. 0 to minus 2. That means what? 2 electrons gained. 2 electrons, but since there are 2 carbons, into 2 is equal to 4. N is equal to 4. Okay, so E reduction is equal to, there are 2 molecules, CHO. Okay, 2 molecules, so 2m by n, n is equal to 4, so 2m by 4 is equal to m by 2. Okay, so E net is equal to E reduction plus E oxidation. Okay. That means m by 2 plus m by 2, which is equal to m. Okay. The equivalent mass of formaldehyde is its own molecular mass. Okay. This is equal to 30. Okay. 30 is the equivalent mass of formaldehyde in this reaction. Okay. I hope you understood. If you have any queries and suggestions, please write in the comment box. Okay. Wish you all the best and thank you very much. We'll meet in the next video. Thank you.